Now I'm going to probably stay back here for the most part because I'm recording the class and the microphone's in the laptop set there. I don't have one of those little Bluetooth things to walk around the room. And what I've discovered, or especially for something like this, if I did, the batteries would go dead within about 2 hours. So that there, actually I do have one, but I know that the battery will go dead within an hour or so on that there. So I'm going to just stay back here and just use the microphone there. Okay, that there. Let me just kind of jump through there. As I gave a little background, you know who I am. I've been around for that there, and I thought did I close that out? Yep. Oh, I rebooted the computer. That's why my slides are closed. Right there. And chapter 1. Okay. Okay. Introduction to Matlab for Engineers there. And again, that happens to be the title of the presentation and the title of the book there. I will be real blunt, honest, and say that I made minor modifications to these slides. I didn't really get that there. Like most university faculty, we tend to be overworked and we tend to steal as much as possible from publishers, and I don't consider this stealing since I can log on to, I think it's Wiley's the publisher, and download the slides from the publisher for free. So since they give them to me, I guess they intend for me to use them that there. And for those who aren't familiar, most of the slides that come from publishers, the authors don't write those slides, produce those slides. They pay faculty members a little side stipend to come up with a series of slides. That they're students, perhaps. Yeah, sometimes they pay students. I've made a lot of money over the years doing slides for publishers at there. So, and I've also written test banks for publishers at there and homework questions at the end of the chapters. Usually the author writes the book, and then the publisher goes out and finds people to come up with slides. And they find an instructor who's teaching the class and say, "Can we buy your slides can we buy the slides from you?" That there. So these slides aren't bad; they're not perfect out there. So okay, as I was commenting before the beginning of the class, I am 60 years old coming up here, so I will be sitting down from time to time at there. Besides, since I'm without shoes in this room, I don't know if everyone caught the no shoe rule as we came in that there, but my arches say that my back says I shouldn't be standing. If they're at home, I've got a pair of sandals that I walk around, and it's got arch support. Got there. So here I didn't bring my sandals, or else if I knew I couldn't wear shoes, I would have brought my sandals. So, yeah, this chair is low. Can I raise it? Out there. Okay. Out there. All right, the first part of this is actually going through the Matlab desktop, and I'm going to be bouncing in and out of the slides, going back and forth between Matlab and the slides, and probably OneNote that there. So my teaching method is not that I just go through the slides that there. So, but this is what the desktop looks like that there. And right here, this is the typical startup desktop. Let me just go through here and right there. Again, this is for I'm running version 2015. You should have version 2014 on your computers. They look pretty much the same right there. I didn't see any differences when I was running 2014. Actually, I had an old version of 2012 I compared to. I don't have a version of 2014 right there. And I think the University KL has to renew their licenses every year, or not every time they want to buy a new version, they have to pay for it. And Matlab is quite expensive. That there, I happen to be a professor emeritus from Purdue. I retired from there a year and a half ago, 2 years ago. So I still use their software for my personal use at there. So that's why I've got a different version than you do. They didn't have 2014 on their server. And I don't think you're licensed to install it on your personal computers. That's probably the case. But that's not a problem, because I'm going to, as a matter of fact, now is a good time anyway. Almost everything that I'm going to be doing in Matlab can also be done with another program called Octave. So you So an octave is, and don't try this with their computers because I think he's only got 4 gig of RAM at there. But octave right here, and preferences at their workspace right there. Actually, editor documentation. This is not the help. I wanted to put it. Okay, this is more like at their command window. Yeah, the command window is shown there. And let's see what. There's the editor. Okay, this is Octave right here. And Octave is a shareware version right there. If you just do an internet search on, oh, I'm not connected to the internet here. Let me see. If I can connect here.
Have you signed up for the internet, the Wi-Fi?
Yeah. It should come up and make me. I was on the internet earlier. That's why I'm surprised I'm not on the internet that there, but okay. It's actually slow, but if you just do an Octave 4.03 is the most current version.
It's OCTA, right?
Octave, yeah. I can't spell. Yep. Right there, yeah. Right there, and again, right there, and if you just download the version right here, 4.03, 4.0.03 is the current version right there, and that runs under Windows 10. 4.0 doesn't. It crashes, so 4.03 is what you need right there. For your,
we have Windows 8. Is it okay?
yeah, Windows 8 is okay. That's there. So, but again, that's the version that I'm running, and you can put that on any computer. You just download that and install it. It's free right there. So that there, and I will probably use that for most of my presentation, just simply because if you want to follow along, and eventually I'm going to convert this over to an online course at there, and and that would have to use the shareware version right there. But I would not say that there's any huge advantage to Matlab over Octave other than until you get to Simulink right there. Simulink is a toolbox, and we'll talk about later. So the toolbox is right there. So, okay, that's it. So again, I'm just going to jump in here, and as you put the two desktops side by side, you can see they look somewhat similar to each other. Right there. They're not quite the same out there, but they're very similar to each other out there. So with that said, right there, this is a basic here, and we've got 3 parts of this window right here. We've got our command history. These are all commands that we've typed before. We can come over here and click on it and run an existing command, an old command. We've got our current directory, and that's important as we write M files or scripts, and we'll talk about scripts later this morning here. That there is that we want to save them someplace where we know where they're at, right there. And then we've got our command windows, and this is where we do most of our typing right there, right there. So as I come back here and I bring up my Matlab, right there, and here I've got my workspace right there. I don't have my command history. Again, I can close these off right there. Right there. And hide various toolboxes right there. And again, this one's right there. Your environment layout right here again. This is the default. I can turn off the workspace right there. I can lay out. I can put the command history docked right there. So there's my command history down there. You can, again, you can move things around in the window right there. Right there. So you can play with that there as far as setting up your command. And again, the same thing with Octave over here. It's a little bit different, but you can see I can take there, I can move the file browser up, I can resize this. This is my workspace. This looks very much similar to that there. And over here I can start typing my commands. In other words, I can say X is equal to, and I'll explain this command, 0:0.01:2 times pi, bracket, semicolon. I'll explain this command later right there, but Y is equal to, and if I can hit the equal key instead of the base bet there, 5 times sine X, right there, and plot X, Y, right there, and I end up with a little plot right there. And this is an Octave right there. Now Octave shows that as a pop-up right here. Actually, it doesn't. It's just because I've got my screen resized, I can't grab that. Welcome. We out there. So in order to close this window, I have to close it right there. And again, I can do the same command here in Matlab. Actually, I've already put in the first command there. Y is equal to 5 times sine X, and plot X, Y, and the graphs look different because the first one I said from 0 to 2 pi, this one from 0 to 4 pi. So it just gave me 2 cycles right there. So as you can see, between Matlab and Octave, the commands are exactly the same and the results are very similar to each other right there. So that's why, to be honest, for a freshman level course or a sophomore level course on MATLAB or introducing your classes, Octave is probably as good as MATLAB. And students have the, I like to use, and again, this comes back from living in the U.S. where, the Battalion Street software is not found readily or encouraged or even talked about. I like to find free versions of the software that I can just give out that there. So that's like electronic workbench. I don't use that. I use PSpice. That there.
There is another one that one lecturer was teaching controls using one free software as well. I forgot the name. Start with S. Scilab. Do you know what Scilab?
I've seen Scilab.
Is it same?
It's similar content. Scilab, I think actually, and I've never used it, I think is a Simulink version of that there. It's a Simulink copy that there, and it probably plugs into Octave right there, because Octave is the big MATLAB copy one, and I think the one you're talking about, SimLab, I think is Scilab. I'll do a search on it during the break. So that there, but again, these are all that there. The only difference is that you don't get any documentation with them other than what's provided online, and you don't get any tech support. Although my experience with Linux and Octave has been that the tech support from the forums is probably as good or better than what I get from the manufacturers out there. So again, this is the basic window, what it looks like right there, and we'll look at this in a lot more detail in the next couple hours right there. And I don't know what time you said tea break is scheduled, but you said
I think around 10, 15 or
10:30, 10:30. Okay, get there. So okay, entering commands. Again, MATLAB contains there's the command history. We use the up arrow to scroll back through the commands, and I'll go through and show a quick demo of that. Press the key once you get to the. You can also use the up arrow to find a command, to bring up the previous command and correct it. You don't have to retype these long commands right there. And use the down arrow that there. And edit using the left and right. So all that's saying is that if I want to go back and change this to a 2 pi plot, I just use the up and down arrow. I'm just hitting the up and down arrow. Or I can come over here and double click it over there. Now if I double click it over there, that just re-executes that command. I don't usually use the command window to do that. I usually use and you gotta go over and click on the right window, right there. I use the up arrow, and then I can sit there and I can say, I wanna make that 3 pi, right there. Now, if I make that 3 pi, it's one of those things that you think that you've changed y. At this point, I have not changed y. So I got to go back and redo this command there again. Because if I redo the plot, this is all, it's going to still, okay, this time it gave me an error. And that's good because the error just proves what I was talking about, is that y is, right now my last x command, I did 3 pi, right? And the last time I calculated y, it was at 4 pi. So y and x are different sizes. Because the command, and let me just kind of explain this command right here, right there, while I'm talking about this. This is setting up x as an array. Right? In a sophomore level class, I have to review what an array is, believe it or not, at this point. There. But this sets up the initial value of x is 0, and I'm going to increment x by 0.01 each time until I get to 3 pi. Now, if I take the semicolon off right there, so my command, my command is x, and pardon me, this is one of the problems with technology, is if I touch the screen with the palm of my hand, I have to take the battery out of the pen and put it back in. I need to try to, but x is equal to bracket right there, the starting value, and why is this starting value? I carry a spare battery for this reason. Right there. And I thought I carried a spare battery for this reason. And I don't have a spare battery for this one. These are both AAAs. I need a 4A. 4A. You know how hard it is to find a 4A?
I have not seen one.
Here's one.
Okay.
That there.
I don't think I've seen one.
Yeah. Yeah, I think Harvey Norman is about the only place that sells them here. The starting value, colon, the 0.01, which is the spacing. I'm just going to say spacing. Right there, colon, 2 times pi, and that's the end value right there. Right there. So that's I will try to avoid using the pen. I can actually use my, right there. Yeah, it won't let me use that there. I have to use the pen right there. Okay. All right. So getting back to that command right there. So again, we said that x is equal to 0 colon 0.01 colon 3 times pi. Now if I leave the semicolon off.
So this would be like a set of values.
Yeah, right there. So this has got a value of, and let me close that, and let me add the worst space. So this says that this is going to set up X right there as as an array of 1 times 943 values right there. So this tells me right there the size, and here's value 9.42 is the last one, 9.41, and I can scroll up through here and see, and we got to scroll up a long ways to get to the top here. That starts at value 0, 0.01, 0.02. If I redid that command and I just did 0.1 right there, now it's only 95 values. But as you can see, that the start here, it still ends at 9.4. Yeah.
What's double?
That means it's a double precision floating point number. So if you're a programmer, you would understand if there's integers, single precision, double precision, Boolean values. That's the type of variable. So it's taking up 4 memory locations. But it's basically a 32-bit number right there, and it's stored as a floating point number. You know, for those who are not programming types, you don't need to worry about what double is or single or something like that there. But again, if I did again another array, say x is equal to, let's just use k is equal to 0, 1, 100, close colon, right there, and right there. And again, that set it up still as a double, even though I could have set it up as an integer right there. But that there, and I could double click on this right here. I could double click on this here, and this shows it in a spreadsheet form right there. And I can actually edit the spreadsheet and enter these arrays this way right here. And this actually is handy if you're going to do like a 5x5 array or a 10x10 array right there to use the spreadsheet. It's covered in one of the slides later on, so I'll go through it again. But you just double click in the workspace right here, right there. And that just shows it in a spreadsheet. And again, we can do the same thing right there. And I'm just going to say X is, oh, I got it. Yeah, I'm not going to say anything right now anyway. X is equal to bracket 0, 0.1, 2 times pi, close colon. And why am I doing that? Because I've been teaching C right there. And I can come over here and I can double click on this. And it's supposed to bring up the spreadsheet. Maybe that's one of the differences right here. Oh, because this is right there. Oh, I guess that is one of the differences that Octave doesn't have that spreadsheet capability. So that is one of the differences right there. So very few people use that. Okay, getting back to the slides right there. Really, what I was trying to show is using the up and down arrows to scroll through and editing the commands. You saw me do that several times when I put the brace there instead of the bracket right there. There are places where we use braces, and there's places that we use parentheses right there. So, okay. Press the enter key to execute the command right there. So, now we can treat Matlab, and I've seen a lot of students do this as a cheap calculator. It's actually a very expensive calculator, but all we have to do is we can just simply, if their CLC clears the screen, clears all the workspaces, a couple commands that they're covered later in the slides, but I just want to clear the screen to make it a little easier right there. And I could say 4 divided by 2, and it says the answer is 2 right there. 5 divided by 3, it just gives me the answer right there. So that there, I can say 5 times the sine of 3 times pi plus 1, just the, right there. So, right there. It uses the standard programming. I guess we could have waited a little bit longer. We're going to fill this room up, actually. Wait, once we got a couple more folks coming in. Welcome. We haven't gone very far, so. Right there. Yeah. So basically, though, we could just type in commands right like that right there. And you see the examples they gave is, the R is equal to 10 divided by 8. That there. Now, if we want to use variable names, and this is something, for example, I can say Z1 is equal to 50 plus, or 5 plus 3i, for example, right there. Z2 is equal to 8 minus 2i, right there. And these, for those of you that have had electrical courses, I'm just treating those as 2 impedances right there. And I want to say, what is Z1 plus Z2? I can just say Z1 plus Z2, and it adds up to 2 complex numbers right there. Now, I also covered there real quick on how we enter complex numbers right there. So, and I can also multiply Z1 times Z2 right there. That gives you the multiplication right there. I can say ZT is equal to 1 over Z1. And I'm going to put another parentheses in here. Close parentheses, plus 1 over Z2. Right there. Now, notice something here as I'm typing is that when I type this, when I put this parentheses in right here, it shows me what the corresponding opening parentheses is. That actually makes it a lot easier to understand, missing parentheses as you're typing commands right there. So, and then I need one more. Now, if I enter this in here, it shows that it's unbalanced right there. It gives me an error. So did you mean, now this particular one is actually a lot smarter. Now, active, I don't think tells that. It comes back and says, is this what you meant to do? Now, those of you who've ever programmed in C probably wish that your compiler would come back and tell you, what command did you mean that? And here it gives me the ZT right there. So for those who are not familiar with that there, if we're dealing with, and again, ZT, and I got to get, ZT is equal to 1 over Z1 plus 1 over Z2 is the, okay, right there. And I did that with this command right here. That's what that there. And that's half of the battle with Matlab is looking at the formula and how do you put the formula in right there. So again, this is a lot easier than trying to do it with a calculator. And a lot of students will probably, especially the first semester AC course, they tend to use Matlab a lot simply because of the way it handles complex numbers versus trying to do it on a calculator right there. It's an expensive calculator, but that's really one of my most common uses for it. I don't use it much as a programming tool right there. So, but you can do it that way. Okay, getting back to right there. So again, these are some examples. It says see pages 8 and 9 in the textbook. Those of you that don't have the textbook, just show up with a thumb drive and you can get a copy of it that way there. So, all right, these are our basic operations. Exponentials, we use the A bracket B. That's the same as you would if you're doing programming right there. Multiplication, use the star. The left division is one that's a little funky because I don't use it very much, but this particular author likes that notation I usually prefer to do the multiplication by the inverse of the matrix. This is actually used for multiplying by inverses of matrices, is what it does right there. So, that's it. Addition and subtraction. So these are typical MATLAB operations, and you saw a number of those already in up there. Okay, order preference, precedence, I say preference, but the order in which things MATLAB does. If you've had any programming, it's going to be the same order right there. My biggest thing that I tell students, and I practice myself, parentheses are my friend, because parentheses is the highest level. And if you look back at I need to close a few windows up there. There's my function I had there. I put parentheses around here, and around here in order to make sure I understood exactly the order in which things are being done right there. So I tend to use a lot of parentheses. So if I go back and I look at my MATLAB right there, you see, other than the fact that I gave it the wrong parentheses the first time, right there, that I've got a parentheses right here. You can see that's that innermost parentheses, and as I move MATLAB over, it highlights the parentheses right there. As I go through there's those parentheses, and there's the third set of parentheses right there. So, and MATLAB actually is very helpful in showing you how those parentheses line up there. But it helps me to actually put the parentheses in the equation before I didn't do it this time because I entered this equation probably a couple of 100 times at this point in my life there. Maybe even in 1,000 times or more. I've entered this equation in the MATLAB right there. But you notice that I put parentheses here. There's one set of parentheses plus and the problem runs into is if I put this in MATLAB and I say 1 divided by, and I don't put the parentheses, and you know what I'm going to do is I'm going to just type it right here. Z is equal to 1 divided by Z1 plus 1 divided by Z2 right there. And that's my command right there. This gets very confusing because what this is going to do is it's going to do this one first right there. It may actually do, I'm not sure, it may actually do Z is equal to, and I'm going to put Z is equal to 1 divided by 1 right there, which is equal to 1 right there, right? So I'm going to then take 1 divided by Z1 plus, and then I'm going to put a parentheses here, 1 divided by Z2 right there. So it's going to do this first, and then it's going to add that to the end. It's definitely not going to give you the right answer. As a matter of fact, we got the answer there. ZT is, I'm just going to write this here, 1 divided by Z1. And I can put spaces in there. 1 divided, it ignores the spaces right there. Plus 1 divided by Z2 right there. And right there is a good enough argument right there. Without the parentheses, I definitely got the wrong answer. Right there. So the parentheses shows that I have to, have them in order to tell it the order in which I want things done. Because I wanted to be, the first thing I wanted to do is find these values here. This value 1 over Z1 and 1 over Z2, add those two together, and then find the reciprocal of that sum. The way we used to say it is ZT is equal to the reciprocal of the sum of the reciprocals. And you say that really fast, you'll get that there. But without the parentheses, you don't get the right answer. It's that simple right there. So innermost, that their parentheses are done first, exponentials are done next, right there. And we evaluate left to right, right there. Parentheses are evaluated innermost pair out, right there. So going back to our right here, our innermost pairs are right here and right here. Those are our innermost pairs right there. So we evaluate 1 over Z1 first and 1 over Z2 first, right there. Then we do the outer pair, which is the sum of the two reciprocals right there. Then, once we've done these parentheses, then we do the 1 over x right there. Now again, if I leave off this outer parentheses, for example, what we're going to calculate is 1 over Z1, and then we're going to add 1 over Z2 to the result. That's still going to give me the wrong answer. I need to have, for the right answer, I need to have all the parentheses there. So, I don't, again, as I go through this series of slide, I don't worry so much about this, this slide in order to remember first, second, third, fourth. I worry more about teaching the students when I'm teaching this in class about the proper use of parentheses to make sure. And usually on a final exam question, what I do is I give them a nasty looking formula and I say, write a MATLAB command for this right there. And what I'm looking for is the correct order of parentheses right there. So, okay. And this is just a series of examples that there, again, this slide is actually messed up right there. But what he's showing here is that the first one, 8 plus 3 times 5, I don't need the parentheses because the 3 times 5 is going to be done first. Multiplication is done before addition. But if I want to do the 8 plus 3 first, then I need to put parentheses right there. Now again, the next one looks like the next one, I don't know what that is. There's a character missing, so the next two are skipping that there, but I'm thinking that there's probably a subtraction done in that process that there. There's some, in other words, he's not going to get there. Let me just 4 to the 12th minus 8 right there. Yeah, I'm not going to worry about that there. This is there's something missing here. Right here, there's something missing.
2 minus 12.
Yeah, there should be
2 minus 12.
that there. There's something missing here, and now my pen is
2 minus 12.
2 minus 12. Yeah, that there 2 minus 12. All right, there's something missing that there, and I'm not going to worry about that there. Again, I didn't catch that when I went through the slides. Actually, I think I was using these last week that there, and I didn't catch them that there. So,
Book, right?
what?
From the book.
It's from the book, yeah. So if you went to the book right there, and pages 11 and 12, somewhere in that area is where it's at in the book. Oh, that's right. That's what the one I wanted.
Is Matlab similar to LabVIEW?
No, they're completely different. LabVIEW actually is a much more powerful type thing, and you can do programming with LabVIEW. The main thing about LabVIEW is it connects with hardware. There's oscilloscopes, function generators, and you can actually design an entire test stand using MATLAB.
Not in Matlab.
Or me in LabVIEW. LabVIEW is is actually owned by a company called National Instruments, and they actually build a lot of lab equipment. So LabVIEW is a way of controlling the lab equipment out there. Back in my early days, now I'm really showing my age. We used to design test stands for testing, boards and electronic circuits. And what we would use is a Hewlett-Packard Hewlett-Packard test equipment and a Hewlett-Packard desktop computer that ran a version of BASIC called Rocky Mountain BASIC. And we would write to all the lab equipment using the IEEE 488 bus in the back, which I'm sure no one's ever heard of an IEEE 488 bus out there. But we used to be able to design lab equipment using BASIC, and Matlab LabVIEW replaces that type of activity right there, where it connects with the real world, and you can get A to D converters that plug into computers that work with it, and it's actually used to interface with the real world. LabVIEW MATLAB is more just a calculation tool and programming tool. Yeah, right there. We said we wanted page. And we were just looking to see where the mistakes were. And all this is just garbage at the end. This starts off, this is actually page 3. And there's the desktop. And again, yeah, he's just missing the minus signs right there. See, the minus signs right there. So, all right. Evidently, whoever copied and pasted that into the slide left out this minus right here. Right there. So again, that's there. So again, you could go through and you could practice this that there, and I don't know, should I have people just go ahead and practice it that there, test it, or it's fairly straightforward on doing that there. Do you have MATLAB up on your computers by any chance? As I'm going through this, it might be helpful to have MATLAB up and just try these as I go through them right there. So
we may need some time to work on it.
Okay, that there. So, but again, this is one of the things. I know when I went through this in my class last week, I actually stopped and made everybody do this. That there. But I'm talking, 18, 19-year-old, sophomores that they're, second year students that they're. If I don't make them do it in class, I can't count on them going back to their hostels and putting that there. We're dealing with professionals. I shouldn't have to sit here and make sure you do this step by step. That there. I actually had to walk around the room and check that there.
We can do the same thing using Octave. Huh?
Oh yeah. Octave.
Shouldn't be any problem. Huh?
Yeah. The only thing I've found so far with Octave is that it doesn't let me double click over here. But again, I can just simply say x is equal to, or 5 divided by 8, get the same thing. 8 divided by 3, get the same thing right there. So again, the same thing as I had before. Z1 is equal to 5 plus 3i. Z2 is equal to 3 plus 4i. Right there. ZT is equal to 1 divided by 1 over Z1 plus 1 over Z2, close parentheses. Now, Octave doesn't do that nice little bluing.
Error, any error message if you do wrong?
What's that? That there?
Any error message, okay? No?
No, Octave doesn't give me a message out there. It's doing something. I broke it. Right there. Evidently, okay, finally it did something.
No error. Huh?
Yeah, no, it's waiting for that other parentheses is what it's doing. That there's it's so everything works with Octave, but Octave's free. MATLAB is about 1,000 to 1,500 USD per copy.
USD.
Yeah, So you're talking 4,000 to 6,000 ringgits for
And that is yearly fee or perpetual?
that. I think that's for one license.
Yeah, but
For
perpetual
one,
or yearly.
that's not a yearly fee. That's to purchase one version, but no upgrades.
No.
Yeah. In other words, you get the updates, but not the upgrades. So if you buy, if I went and bought Matlab today, I would get licensed for 2016. 2017 comes out next year, I don't get it. Not there. So if you want the upgrades every year or so, that there. So, and again, when we look at the U.S. versus Malaysia, U.S. universities tend to get bargains on that stuff. Malaysian universities don't get bargains when they deal with American software vendors. I'm sorry to say that, but in Malaysia, people pay 3 times as much for software as we do in the U.S. Right there. So that's just a difference. And really the difference comes in tax laws right there. So, but again, as we go back here, all these commands will work in Octave. It's just the Octave error checking is not as robust right there. Again, it's free right there. And, Octave, for students having some weaker error checking isn't necessarily a bad thing. Right there. If I'm an engineer and I'm paying someone $100 an hour, or an engineer costs 100 ringgits an hour, engineering time, I don't want my engineer spending time looking for errors. That there, I want the software to find the errors. But if I've got a student and they're putting errors in them, I want them to spend 2 hours looking for that error because that's the learning process right there. So a lot of times I don't encourage software that's too easy to use. I want students to struggle a little bit. But again, some people say I'm mean. That there. All right, the assignment operator is just simply, we've already done it. We assign x is equal to 3 at there. I've already done some of that there. So we could put an algebraic expression on the other side that there. All this is saying, and again, this is for the non-programming students, that I can't put in an algebraic expression such as, and I don't know if this will work or not. Yeah, okay. X plus 2 equals x divided by 5, for example, or y or whatever. And we can't put in 2 variables and 2 unknowns like this and expect it to solve that. Now later on we'll look at that right there. But we also can't say x plus 3 is equal to 7 and and have it come back with x is equal to, we have to change this to x equals 7 divided by 3 right there. We have to go through and solve. The only thing we can have on the left side is the variable right there, because all this is saying right there. X is equal to 3. We can't say x is equal to x plus 2. Or we can do that. That's perfectly legit, but that's a programming statement right there. It takes whatever was in x and replaces it with x plus 2. That there. Algebraically, that doesn't make sense. We can't say x is equal to x plus 2 right there, unless x is equal to 0. That's the only way that there. No, we can't even do that because then that there.
What does that mean? But in algebra, 0 is equal to 2.
What's that?
Implies that.
Well, this assigns a value. If we say x is equal to x plus 2, this assigns a value of 3 plus 2 to that there. But in algebra, this implies that 0 is equal to 2. Yeah, because all that's saying is that we can say, let's just say x is equal to 5 right there. So then I can say x is equal to x plus 2 right there. And now x is equal to 7 is all that's doing right there.
Line by line command.
Yeah, it's a line by line. Yeah, and you can see that over here in the workspace. So I can say x is equal to x times 2. Right now x is 7 over here. As soon as I hit the enter key, it'll go to 14. I did it times. Yeah, I did times. Let's start with that. So all this is doing, and it's just like if you write a computer program. I can write a computer program in BASIC that says, x is equal to 5, x is equal to x plus 1, and then inside the next loop, x is equal to x plus 1, right there. I could write a for next loop, and it will do for next loops in MATLAB too as well. MATLAB also is a programming language. That's there. So, that's there. Okay. Let me know whenever you think the break.
We are ready.
Yeah, yeah. I hear cross conversations that usually tells me that people are ready for a break.
Okay.
That there. So I'm going to. That there. All right. It's 50 minutes. That's